So today I am going to attempt code lead code hard problem. I haven't solved this problem before and this is new problem for me. I am going to I will try to solve it and try to I will try to put my idea how can I approach the problem hard problem. That's what I'm thinking of. So I'm just attempting the question just that I'm just attempting. So let's see how we can approach the problem, hard problem. So that's what I am recording myself. These problems I haven't solved yet. So I'm going to solve it. This first problem I have tried. Today I have tried this problem, but unable to solve this problem. You can see the submission. I have three wrong submission on the problem. These problems I haven't solved yet. You can submission is not done. And also I am not very good competitive programmer. So not the case that it is very easy for me. So these problems are not easy for me, but I am trying to attempt it. You can say that it's real as attemptation. You can say that how you can approach. You will learn here. I think so. I try to put my idea. So this is the question we have. You are given and all the problems belongs to greedy section of lead code. I have taken the greedy section, hardest problem from the top. Acceptance is very low. This way, I have chosen the question. Let's attempt the first question we have. You are given an integer array nums containing distinct number, and you can perform the following operation until the array is empty. First element has the smallest value, remove it. Otherwise, put the first element at the end of the array. Return an integer denoting the number of operations to make nums empty. So you have given a nums array which contains distinct numbers. All numbers are distinct. No integer is going to be repeated in this array. And you can perform the following operation until the array is empty. And you can perform many operations so that until the array is empty. If the first element has the smallest value, remove it. So if you have the array and the first element has the smallest value, remove it. Otherwise, put the first element at the end of the array. So now you have to tell that maximum number of operation you can take. Return an integer denoting the number of operations. So you have to tell that how much operation you will need to make this array empty. If the number is a smallest one, a smallest in the array, then you will remove it. Eh? That's what we want to do. And if it is not the smallest, then what we will do? We will just pick that element from the first and put that element at the last. That's what we can do. So, and let's look at the constant we have given. So 10 to the power 5. So the size of the array we have given is 10 to the power 5, and the numbers present in this array will vary from minus 10 to the power 9 to 10 to the power 9, and it's guaranteed that the array given you will have the so the condition is so the first thing we have given is nums array we have given. The second thing we have given is distinct word we have given. That means the numbers present in the integer present in this nums array will be distinct. That no integer is going to be repeated in this nums array. The third thing we have is we want to make it empty. So what we want to find number of operation make nums. So that's what is the target you are looking for. This is the output we are looking for. So we want to find this number of operation, these number of operation, and the operation is defined like that. So number of operation we have to find. And now the operation. What is the operation? So we have given two information about the operation. So let's say at any stage of the solving this problem, some numbers remain in this nums array. Some numbers will left and some will get removed. So at this stage, you will check that the first element in this remained nums array is actually the smallest one of this nums array. If it is, then remove it. If this topmost element, that is first element of the remained nums array, that is some numbers got removed from this nums array and the rest remained in this nums array. So basically the question is telling that check that the first element remained in this nums array. If it is the smallest one in the remained nums array, then remove it. Otherwise, pick it and push it at the back of the array. That's what the target is, and remove it. So your new nums array will start from here and will go here. Likewise, you want to do operation, and after doing all these operation, what we want to find? We want to find the number of operation we will check to remove all the elements from this nums array. Now, let's talk about the constant we have. From where I can add page. How we can editor mode. Editor. How we can select add page, select erase, add save, add text, download. What is this? Background. Add new board. So I am adding the new board. And uh, and now let's talk about the constant. So the size of this array, the array we have given, will be of 10 to the power 5. That's it. And one more thing, nums I, that is element present in this nums array, will vary from 1e9 to -1. So these are the information we have given. So the given constant, from the given constant, we can easily know that we can't write a solution of order of n. Can't write a solution of order of n. So because n square will go to 10 to the power 10 and it is not going to run in 1 second, so our solution will give TLE. If this was not the case, then we can actually do a solution of n square. And n square solution, what do you think about how can you write the solution of n square? So let's talk about how we can write a solution of order of n square. It's simple. Let's you have a cube. Let's you have a cube. Okay? Let's you have a cube. Push all the element in the same order as it is present in the nums array. So insert the all elements from nums array to this cube. So your cube will have all the elements of the nums array. Now pick the first element. Now also make a set. This is cube. We'll make, and let's make a set and also insert all these elements in this set. Now what we can do? We will pick the top element of this cube and check that the first element of this set is actually equal to this element or not. If it is equal, then it simply means that the remained element you have all the remained elements in the cube, and in those remained element, this topmost element is going to be the smallest element. So you will simply remove it. Okay, and you will delete this element from the set. It will take log n. Okay, so n times you are going to delete. So the deletion complexity will be n log n, and n square times, in worst case, you are going to check that this element is at the top or not, at the first element of set or not. So this is going to take n square log n. N square log n, it will not actually log n, it will be simply n square, because the first element you will check in order of 1. So it will take n square operation. So these are the complexity on the set we are going to invest. Now talk about the queue. So in worst case, it may be you will check that it is the least element, the smallest element at the top or not. If it is a smallest one, you will simply remove that element, and the number of operation is going to increment by one. And if it is not the smallest one, you will simply push it in the back and remove from the top. So in this way, you are going to do the things. So likewise, you will take n square in worst case, n square times operation you in the worst case you can get. For removing one element, it may be the case that you have to swap n elements at the back. It may be the case, and this case can repeat. So the worst case solution is going to be n square if you simply write the brute force. So we are looking for some better solution because this solution is going to give me the TLE. So what we can do? So what we can do? Now we are talking about the optimization. How we can optimize the solution? Okay, how we can optimize the solution? So let's optimize. Let's talk. Optimize it to optimize it to n log n, or if you can do it in n order of n, then also very good. You can do it in order of n. The best. If we can do it in n log n, then also it will work, and it will be good solution, better solution. So how can we do it in order of n? So what are the key points? What are the key? We have the elements. All elements are distinct. So let's see. Let's see. You have this array. You have this array. Okay. You have the array, and at this instant, whole array you have. You will check that the smallest element is present at this place. Say the smallest element is present at this place. So all these elements you have to first put at the back. So these elements which are present before this minimum element, let's say the number of these elements is x. Okay. So these x operation. So you have to take x plus 1 operation to remove this element. Okay. Now this is the for removing the first element. Let's say after removing this element, the second element is somehow second element is present at this place. Let's say second largest element. Then how much operation it will take to remove? First is going to be x plus 1. Then it will take how much operation? 3 operation it will take to remove from this array. So now talk about the third. How much operation the third will take? Okay, how can you find that the third will take how much operation? So let's say third is present at this place. At this place. So it is going to be somewhere, let's say y element. So it is going to be at somehow at this place. So the number of elements after this is, let's say, z. So z plus y plus 1 operation is going to you have to do. So likewise we have to do operations. Okay. Likewise we have to do operations. These are the cyclic. How it is going to work. Okay. So as it is greedy problem, definitely there will be a keen observation. Somehow we have to analyze that observation. What we can do. So if we want to implement the solution like this, that I will first find the element. I will first find the smallest element, and we can easily find the number of operations to remove from this array. After that, what we can do? Position of second element we can know. Huh? Position of second element we can definitely know. Na? So relative position of second element will be, let's say I1 is the index of first element. I1. I1 is the first element index, smallest one. And the second smallest is I2. Third is smallest I3. Fourth is I4. And fifth is going to be I5. And so on, it is going to be at IN. So let's say these are the indexes of element. If let's say I am sorting this, I am sorting the array. Let's say what we can do, we can make the, so let's say we have the smallest element which has index I1, and the second smallest has index I2, and the third smallest has index I3, the fourth has I4, and so on. The largest one has index IN. So these are the indexes value we have. So to remove this element, first element, we can simply know how much operation it is going to take. So its index number plus 1. I1 plus 1 operation you will take to remove the first element. Now talk about the second element. So what can be the cases? The cases can be very simple. Cases is going to be very simple. What is the cases you have? Cases is very simple, that this I1, this I2 is either can be in the left side of I1 or can be in the right side of I1. So these are the two cases we have. If it is going to be at the right side, then simply I2 minus I1 plus 1 operation it is going to take to remove from this array. So first going to be I1 plus 1, and then it is going to be I2 minus I1 plus 1. And likewise, what can be the cases? If it is at the right side, then it will take this much of operation you have to take. If this is not going to be at the right side, it is going to be at the left side. So what are the cases we can have? So the number of element going, so it is basically I2 minus I1, the number of elements in these ranges. So we have this element, and before this, let's say there is number of element is going to be x. So basically you will put those x element in the last of the queue. So you have to remove all these elements first, and then you have to remove all these elements. So it is basically n minus I1 plus x plus 1. This much of operation you will take. Okay. Now, what are the cases we have next? Talk about I3. And I1 and I2 got removed. I1 was somewhere like this. I1, all those element get pushed here. These all going to be pushed here. I1 got removed. This I2. This. Now I have removed I1. Then the situation should be like this. So these are the boxes, range we have. So we can make a pair of nums I comma I, sort that array. And in this way, we can arrange according to their from smallest to largest, and also can store their indexes. So the first thing we should do is make a pair. We should do, I think, this direction there will be solution. So make a pair of nums I comma I, and push all these pairs in a vector. Let's say and sort this vector. Sort this vector. This is the thing we can do.
करिया तू है मेरे आदिवासी कैपिटल
आगे देंगे।
स्टूडेंट
बंद करना।
गॉट रिकॉर्ड करना
क्या आदमी है रे तू? बंद करो ना। बंद कर। So how can we proceed from here? So let's make the pair and sort it. After that, what we can do? See, the problem is have the problem that I1, I2, I3, I4, I5. I1 is I1 is good, and you are talking about how much operation it will take to remove I2. How we can do that? After removing I1, there will be part of the array. There will be two part of the array. What will be the part? Part will be very simple. That you want to delete I2 now. So two part is going to be. After deleting I1, there will be two part. First part will be 0 to I1 minus 1. 0 to I1 minus 1. First part is going to be. Second part is going to be. Second part is going to be in the. Where it is going to be. Second part is going to be. Let's say. Second part is going to be I1 plus 1 to n. This is the two parts we have. We are going to have. These are the two parts we have. So what we can do? Basically, these parts will be at the front. These parts is going to be at the front. This first part is going to be at the front. This part is going to be at the front. Simply going to be at the front because it is got removed. Pushed at the back. These elements from 0, I1 minus 1, it is going to be pushed. And after that, you will have I1 is got deleted, and you will have a part I2 plus 1, which is actually left. I1 plus 1, I1 to 1, and you have. So these are the parts. So how your vector will be look like? If you are going to delete the first element I1 present at I1, then your vector will be changed like this. It will change like this, that all the elements from I1 plus 1 to n is going to be the first range you have, and the second range is going to be 0 to I1 minus 1 like this. Now you have the second element. How can we go for this second element? Let's see. Now you have I2. You will check that. You will first pick this range. Let's say I am storing these ranges in the same order we have. Same order. I am storing these ranges. Somehow, let's say I am storing these ranges. So what will happen? Let's see what will happen. What is going to happen? Let's see. What's going to happen? You want to delete I2, and you want to know how much operation it will take to remove this I2. So it's simple. You will iterate. Somehow I have stored the ranges, let's say, making pair and store the ranges in the same order we have. So I will pick the first range and check this I2 is belonging in this range or not. If it is belonging in this range, that simply means I will delete this part. Let's say your I2 is going to present somehow between I1 plus n, 1 to n. Your I2 is going to present. Then what will happen? It will simple. What will happen? Tell me. The simple thing which is going to happen is nothing but for deleting I2, you have to push all these elements at the back. And for pushing all these elements, you will simply do one thing now. You will make a pair of I1 plus 1 to I2 minus 1 and push it at the back. And you will remove this I2. And this part is going to be at the top of your the data structure in which you are storing will be at the top. So it is going to be I2 plus 1 to n. So in this manner, if I am able to store the manage the things, then we simply have the solution. Okay, we simply have the solution. So let's talk how we can handle this solution. So let's talk how we can handle this solution. So we can simply make a DQ. Let's say, as we know, from DQ we can push from the in DQ we can push from the front, and we can also push from the back, and we can also remove from the front, and we can also remove from the back. So this is the data structure we can use here. This is the data structure we can use here. So what we will do is we simply will do some this thing. Initially, we will have a DQ. We will have a DQ, and this DQ is going to store pair of int comma int. This DQ is going to store, and it's basically the name is, let's say, DQ. I will initially put the indexes. No, I will initially put a pair 1 comma 0 comma n minus 1. If the number of element in the nums array we have given is n, then I will put a pair 0 comma n minus 1 in this DQ. I'm simply going to put, and as we have talked, we have a sorted array, and we will make a pair of our nums array. That vector is going to store in the, we will make a vector. Let's say we will make a vector of pair of int comma int. Let's say the name of a vector is vec, and I will simply store the pair nums I comma I in this vector, and then after pushing all the pair, I will simply sort this vector, and after sorting this vector, we will have a vector in which the element present in the sorted order. First element is the smallest one, and the second is the second largest, third largest, so on. And we also know the indexes of all those elements. At which index those elements are present in the original array. We know that. Huh? Now I will simply pick the elements one by one. One by one, I will iterate over this vector. I will simply iterate over this vector and pick the elements in the same order present in the vector. And then what I will do? I will simply check our DQ. Start iterating our DQ. So start iterating our DQ. I will simply then start iterating our DQ. Let's say we are present at the index I of this vector, and we know at the element present at this I index is, let's say, x comma ind. That is, in the nums array, x was an element present in the nums array whose index was ind. That simply means that thing. And you want to know that how much operation I will take to delete this element. You want to know? So you know, and you have a DQ. And for finding this, you have a DQ. In DQ, there are pairs present in this DQ. The pairs are in the same range. The pairs will tell you L comma R, L1 comma R1, L2 comma R2, so on. These are the pairs we have. So you know the pairs. Simply you know the pairs. Now what you do? You have the pairs. What you can do? You will simply check. Pick this first pair. You will check that. Is it present in the IND? This IND index is going to present in the range L1 comma R1. If it is present, then you let's say if IND is present in the range L1 comma R1, then to remove the IND element, you have to remove all these elements present in this range. You have to remove, na? You have to remove. And to removing this element, the number of operation you will take, let's say IND minus I1, IND minus L1, na? Number of operation you will take. So this is the number of operation you are going to take to delete IND. So it is going to be IND minus L1. Simply goes like this, and you will delete this. After that, your ranges will break. So your ranges will break and become L1 comma IND minus 1. One range is going to be, and the other range is going to be IND plus 1 comma R1. So this is the range you are going to get from here. So this range, the first range, is the elements present in this range is going to be pushed at the back of the queue, because these will get swept, and we will push those elements at the back of the array now. So we will simply put this range in the back, that is L1 comma int minus 1, and we will remove this range from the queue first, L1 comma R1, and you will push this range int plus 1 comma R1 from the front. So we will, if this L1 comma R1 is going to be, your int index is going to present between this L1 comma R1, we will simply do one thing. We will remove the top range, and we will push int plus 1 comma R1 in the top, and we will push L1 comma int minus 1 at the back. And if the int index is not going to present in the range L1 comma R1, then simply means we will pop this element from the queue from front, and we will push it at the back, and we will iterate like this. So this is the optimized solution we can have. This solution will be very better using DQ. So let's code the solution we can have. So let's have a DQ. D Q Q. Let's make a vector. So vector of pair of int comma int, and its name is vec. Now I will simply iterate over the nums array. I will simply iterate over the nums array. I less than nums dot size or I plus plus. So I will simply iterate over the nums array, and I will push all the pair. I will make the pair of nums I comma int and push these pairs at the back of the array. So it's basically nums I comma I. And after doing this operation, I will sort vec dot begin comma vec dot end. So we have the sorted things. Now I will make a DQ. DEQUE. So what is the syntax of DQ? DQ in C++. DQ in C++. Let's see the syntax of DQ in C++. STL. So this is the syntax we have. So let's write this. So I don't want to iterator. So I want to make a DQ which can store a pair of integer, and its name I am putting is DQ. Okay, and I am the first element I am pushing in the DQ is DQ dot push back. In the back of DQ, the first element I am going to push is 0 comma nums dot size minus 1. This is what I am going to push. And now what we will do, I will iterate over the vector of pair I have made and sorted. So it's basically I of 0 I less than vec dot size and I plus plus. And now what I can do next, I will do next. So we have the int int index. This is the, we have the pair, we are at the index I of vector vec, and this, so this index is going to have the two data. First is the value, which is nothing but vec of I dot first. This is the data, and the index at which this data is going to present in the original array is nothing but vec of I dot second. Now this is the element val which was present at int index in the original nums array, and I want to delete this element. So how many number of operation I am going to take to delete this element? So let's say to store the total number of operation to delete all the array is, let's say, answer in which I am going to store. So I will make a long type of data answer. Now the number of operation we will talk about. So what will be the number of operation? I want to know. So let's say make run a while loop. While one. So let's say you have a pair of int comma int, and it's basically tr. Their name I am taking is tr. So what I will do, dq. So I am taking the first element of dq dot front, and copying it in pair pr. So this pair will have two elements. So this pair will have two elements. Okay. So the first element will be a smaller one, and the second will be the larger one. So you have L1 equal to tr dot first, and in the similar manner, int r1 is going to be tr dot second. Okay. So you have L1 and R1. So first check that this L1 and R1, actually this your IND index is going to be in the range L1 or R1, between L1 and R1. So how you are going to check this? So we can simply check this. So check it like this. If IND is less than equal to R1 and IND is greater than equal to L1, that means this IND index is going to belong in the range L1 and R1. So you can, how much operation you will take to delete it? First, the IND index, how can you delete it? This range is, first check how much distance it is from L1. How much distance it is from L1? How much distance it is from L1? So this is the case we can have. So it is going to be IND is less than equal to L1 and IND is greater than equal to R1. This is the two cases we can have. So if this is the case, you have to, how many distance from it is from L1? How many distance it is from L1? IND is. So its distance is, let's say, dis, and it is actually equal to is actually equal to how many operation you have to take? Delete it. Let's say 5, and you are 3. 5 minus 3 is going to be 2. 5, 4, 3. 3 operation. So absolute value of L1 minus IND plus 1. This is going to be the number of operation. So increment the answer, increment. So increment the answer by this value this. So make it long. Make it long line, and answer, increment the answer by the not this. So these are the things we have, and copy these things in at this place also. And if this is not the case, this IND index is not going to belong from this region. It actually means you have to pick all these ranges of element and push it at the back of the dq. It simply means you want to push this pair in the dq dot push back tr. This pair you want to push, and you want to also pop from the front, dq dot pop front. You can pop it from the front side, pop it, and in this case also you will have to pop from the front, dq dot pop front, and in this case also you have to pop from the front side. That actually is, that is actually. And in this case also you have to pop front, dq dot pop front. Now pop we can do, but we also have to push na in these two cases. So 1 to n is going to 1 to n minus 1. We push the, in the dq we will dq dot push front, and the pair will be nothing but ind from index ind plus 1 to ind plus 1 to r1. Push it at the front, and in the back you are going to push nothing but ind plus 1 comma r1 not, it's l1 comma ind minus 1. So these are the things we have. That's it we have. I think there is no need of this case. So these are the, this is the solution I have written. This is the case. That means this element got deleted and take from. We will iterate over the next element. After doing all these things, our answer is good. So I will see what I will do. I will return answer. I think the logic is correct. So I am just running this code. Let's see what's the output. L1 minus ind plus. So it's actually giving minus. It's actually giving 3. But it's, where is the mistake? 1 to ind. L1 minus ind plus wrong. Where it is going wrong. The test case we are getting wrong. T4 minus 1. We have 3, 4 minus 0, 1, 2. 1, 2 minus 1, 0, 3, 1, and 4. This is the vector we will have after sorting. So first pick first element, 0 index. Will it's at 2 index now. Minus 1 is going to get 2 index, 3 is going to be at 0 index, and 4 is going to be at index 1. You want to delete it? So in the queue you have 0, 2 and minus 1. That is actually have 0, comma 0, comma 2. Going to be in this range. So number of operations you are going to get is, so 0, 1 and 2. It's going to, you are going to get three operations. So L minus 2 going to be 2. So we have to do one more thing now. So we have to check if I and D plus 1 less than or equal to R1. Then we can do it. Greater than equal to L1 and less than equal to R1. We will get here number of operations 3, and your order will get changed 0 to minus 1, that is what. Now you will add the first string, delete by 0 operation. Operation, okay, one operation you are going to take. One. It's not counting that thing, no? It is not counting. Got this. Let's see what's the output. It's going to be vec dot begin comma vec dot in dot well tell three operation. 0 comma nums dot size minus top thread dot L1 comma R1 comma I and D. C dot L1 comma R1 comma I and D. Thing wrong. 0 to 2. 2 minus 0 plus 1 yar. It's not actually L1 minus I and D is not equal. There it is. We have to put a plus sign, then we have to put a minus sign, then we have a plus. Now it will equal. Okay. And here also the number of operation is going to be answer plus equal to 1 LL into R1 minus L1 plus 1. This is the logic we have. It's working. Let's check it on the sample test. So it's giving correct output. All this. So this is the modification. Submit it. I think the complexity is good. But and on 4 test cases, it is giving wrong now. So it's actually good. Good work. Let's remove this console and see. See. Oh, so it's failing on some test cases. 3, 4 test cases going to fail. Last it is going to fail. Work here. In worst case, how the ranges will break? How the range is going to break? Worst case. If I will talk about the worst case, how the ranges will break? Say range will break like this. One range will break. Then you will remove it. Second element like this. Again. Worst case, how the complexity will go logic. You have to optimize more. EQ is not going to give that much of Actually a same beautiful solution that we talk about in worst case. Here it is acting like that. That's not. तो ये सॉल्यूशन तो मतलब काम नहीं कर रहा है, डेली दे रहा है फर्स्ट। बात है कि हम ब्रूट फोर्स सॉल्यूशन का बात किए थे, ये उसी टाइप का सॉल्यूशन जा रहा है वर्स्ट केस में। हम इसको इनपुट नहीं कर पाए हैं कि शायद उसी तरह का केस बन पा रहा है कि नहीं बन पा रहा है। लेकिन अगर हम इसी को ऑप्टिमाइज करने का बात करें तो क्या हम यहाँ ऑप्टिमाइज हो जाए, क्या हम कुछ कर सकते हैं? पावर फाइव लार्ज टेस्ट which it is last test on that। क्या दिक्कत है इसमें? फर्स्ट केस होगा इसमें। फर्स्ट केस ये बिल्कुल ब्रूट हो जा रहा है। और के लिए अगर मान लीजिए हम एक काउंट रखते हैं, ठीक है, यहाँ पे चेक करते हैं कि कितना बार चलता है काउंट। और हम काउंट को कितना बार व्हाइल लूप में कितना बार मैं काउंट प्लस प्लस करता हूँ, कितना बार दूसरे बार जो है लॉन्ग लॉन्ग बना लेते हैं इसको। तो देखते हैं इसको कैसा काम करता है ये वाला व्हाइल लूप। सी और काउंट करते हैं और डॉट साइज भी और देखते हैं इसको आगे आइए क्या देता है हर एक एन और T12 साइज के लिए, साइज के लिए आंसर 3 दे रहा है और 12 क्या दे रहा है, वाला दो आउटपुट है। मान लीजिए मैं यार क्यों वाला इंटीजर केवल आंसर होगा, तो देख मैं इसको सबमिट करता हूँ वाला टेस्ट। मात्र 52099 पाँच गुने पावर 4 लंबाई पे फिल कर रहा है लेंथ के 1 4 10 की पावर 4 पे चले गए आप। पावर 4 सॉल्यूशन को 4 9 इंटू पावर 5 पावर 7 की पावर 7 से एक्सीड कर जा रहा है यार, जा रहा है। सेवन का बाद था, भाग रहा है, इसका भाग रहा है, भाग रहा है यार। सेक्शन पावर 8। Of the solution we have also of around order of we need the pair, need the pair or not. Actually, we don't need don't need this DQ. Long answer. Let's the front. Let's say IND equal to 0 currently. But right clicking on this file is what size. I plus you have int value equal to of I dot first you will have int id1 you put it the index id1 but but back of I dot second. So what the next? And we are at id1. So what? There can be two cases. IND is less than, can be two cases. This one like this. Your IND your IND less than IND1 can be your first case, and the next case you can have is nothing but case IND1 less than are the two. In the first case, what will be the number of operation to delete? It's index IND1. So what can be Oh, so in the first case, how many elements you have to delete? I and D, I and D 1. So there can be case that some number got already deleted in the range I and D to I and D 1. If I know the number of elements present in the range I and D to I and D 1 which is got deleted, if I know that, let's say that the number of that element is X, this is the case, then what will be the number of operation you have to do to delete this element I and D 1? It's nothing but long that equal to absolute value of I and D minus I and D 1, I and D minus I and D 1. And one more thing, in those number of operation, this is the X number of operation. If the deleted number of element in the range I and D to I and D 1 is X, then those operation you don't have to do now. That element is already removed. So the number of operation you have to do to delete this I and D 1 index is nothing but what? I and D minus I and D minus 1 plus 1 minus X. This is going to be this value Z is going to contribute the final answer, long answer. That long variable it is going to, that's it we have. So answer plus equal to what? X. Okay. So this is the thing we have. Now how you can find this X value? And after finding, after deleting this element, okay, after deleting this element, if this is the case, so this is going to be in the case if I and D is less than I and D 1, then it is going to be the first case. And if this is not the case, then what will be the case? In else case, you have to find the number of elements which is got deleted, the range I and D plus 1 to n. So if that number of element is X, then the number of operation you have to do to delete this element present at an index I and D is nothing but absolute value of I and D minus I and D 1 plus 1. No, this is not the case. Number of elements you have to delete. So you have to first find the number of elements which is got deleted in the range I and D plus 1 to n, which is X. So and total number of element in the range I and D plus 1 to n is nothing but n minus I and D minus 1 plus 1. This is the number of elements in the range n to I and D plus 1. In those number of elements, X is got deleted. Now you are at index I and D. So you have to also find the number of elements which is get deleted in the range 0 to 0 to 0 to I and D minus 1. Number of element got deleted in 0 to I and D minus 1. So let's say the number of elements which is got deleted in the range 0 to I and D is nothing but Y. If you somehow find this, then what is the value of Z? X plus number of element in the range 0 to I and D, nothing but I and D plus 1. And one more thing, so in these elements I and D plus 1, Y is already got deleted, so you have to decrease now by Y. So this is the value of Z you are talking about. Okay, this is the value of Z we are talking about. Now the next thing is, so this Z is going to contribute the final answer. So answer plus equal to Z. The similar manner here also there will be Z now, not be X. So after this, what will happen? your IND is got to moved to IND equal to IND 1 plus 1. Actually not IND plus 1. It's actually IND plus 1 modulo n, where n is the size of your original array. So that's it. So IND modulo IND equal to IND 1 plus 1 or IND modulo equal to n. So let's make this variable integer. Let's define this integer, declare this integer and put a value, assign it a value. It's basically the size of the array it is going to take. So this is the thing we have. Now how can you calculate this value x and y? Basically this value x is nothing but number of element which is present in the range IND to IND2, number of element which is got deleted in the range IND to IND1. So let's say you have a query. So these are the problem of range query. So you have a query that you are calling a function, giving him some data, and you are expecting that if I am giving it to integer, that is nothing but IND and IND1, then it is going to give me the number of elements which is got deleted in the range IND to IND1. That's it. You are expecting from this query. So after doing this, one more thing, if you have deleted after this incrementing the value, you already have deleted the element present at IND1. So also you have to tell some function update, and you are telling that I have deleted the element present at index IND1. So these are the information you are giving him this any data structure. Let's say you are giving the function update and you are taking the data from query. So these are the two things you are expecting from this function. You don't know how to implement, how it is going to work. If you know and somehow it is going to give you in these results in log n, then your solution will be perfect now. So in the similar manner, what is x? X is the number of element which is got deleted and in the range IND plus 1 to n. IND plus 1 to n. So simply you will call this query 1, and you will tell that. So what you are going to tell it? You are going to tell it that I want the number of elements which is got deleted in the range IND plus 1 to n minus 1. Okay, that's what you are. So here also it will be n minus 1 now. That's it. So similarly, in y you want to find the number of elements which is got deleted in the range 0 to IND 1. Okay, and you are expecting from this query, and after deleting this IND1 index, you will also tell the function update and will say it that I have deleted the element present at IND1 index. So the whole problem is based on our two hypothetical functions. That is query you are going to get, and that is update you are going to do. So this is basically a problem of range sum query. So how many number of elements you are get deleted? The range L to R you want to find now, and each time you are deleting some element at any index IND, and you want to update also that I have deleted the element present at IND1. So basically you should build a segment tree, and that segment tree is going to give you the range sum. So basically at this point we are talking about the range sum query. So I am not going to write the code of range sum query. I will simply use the code of range sum query. So range sum query segment tree, I will find the code from anywhere. Range sum segment tree. So for a given propagations. Here I will find the code. Some range query, range some query. What is segmentary? Brute force solution. Range minimum query. So range some query. Point update range some. Here is the code I think. The class mean segmentary. Dynamic range some query. This is the thing we are talking. I am just copying this code. I'll use this code. Find the range some query. This code. Template class T segmentary segment type of some segtree of type int, giving him the len comma to default. It id well id plus equal to 10 id well, and then one there is no code for pointer set value index पे value set कर सकते हैं how it is going to work. Let's very this is the code we have copied. See how it is working like that. 0 0 0 initially I will put these are the things we have. So, like that I will simply get this value and will be for int I equal to 0 I less than 10 I plus plus I equal to 0 na it what is the name of our seg tree na seg tree dot set at let's I want to put a value 0 initially. Okay, here also seg dot set ind1 comma 1 also here segment tree. I want to. So if I have deleted the value at present at index ind, then in the range sum query, I am putting the value at index ind1 is 1. That is one element is deleted at this index. So if you will find in the sum of the range is L1 comma R1, it will give the number of ones in the array in the L1 comma R1, and that is basically the number of deleted elements in that range. That's it. That's why I am using segment tree here. So ind1 comma 1 like this. What's the next? So now talk about query. So how can we call for query? Its query is like this: segtree dot range sum. Okay, range sum we have. Okay, so query is like this: ind plus 1 to n minus 1, ind plus 1 to n minus 1, ind plus 1 minus 1. So like this. Same goes for this. ind plus 1 was not ind 0 to ind1 na, 0 to ind1. It's basically 0 to ind1. Okay. This is the thing we have. This is the thing we have. Acha. So here also ind to ind1. Here also we have to find na ind to ind1. So ind to ind1. Oh. So this is the implementation of the things we want to implement. So here basically the n is nothing but n. That's it. So let's see it's working or not. We have a segment tree class inside the segment tree, inside a class. Here I have used size SIZD na. So ind equal to 5.6. It's giving 6, but it should give 5 now. Where it is going wrong? We haven't sorted this vector now. We have to sort the sort comes dot begin comma vec dot begin comma vec dot end. Sort this vector. Have to sort this vector. We so actually the solution we have written in segment tree not working. It's giving 6, but it should give 4. It should give 5 now. So I'm trying and run and check it. I will try run and check that it's actually working or not working. Basically the test case we have 3 4 minus 1. Have 3 minus 1. Actually test case minus 1 and index is 0 1 2. Yeah. So after sorting we will get minus 1 3 and 4, and and its corresponding index will be 2, and its corresponding index will be 0, and the corresponding index of 4 will be 1. This is the sorted array we have vector, sorted vector we have. So when we pick first element and its index is basically 2, so its index is 2. So first I will find that how many elements, and our IND value will be 0 currently, and IND1 will be going to be 2. So I will find that how many number of elements which is deleted in the range 0 to 2. So I want to find it. So when I will find it, I will go 0. The number of operation will be 2 minus IND, 2 minus 0 plus 1 is actually 3. 3 I am going to get. After, so our, so let's say we have the array which index I have deleted. So 0, 1, 2 we have. These three indexes we have. So index 2 is got deleted. So now I am at index again. So 0, 1. So I am again at 0 index. 2 plus 1 modulo 3 is going to be 0 now. So again the element is 3. So I will find that from 0 to 0 how many elements got deleted, and I will find that it's a 0. So 0. Basically how much operation I have to do? Actually one more. It's going to be 3 plus 1 is going to be 4. So 0 plus 1 is going to be 1. So 1 modulo 3 is going to be 1. So our IND will become 3. And our third element is 1. IND will become 3. No, no, it's going to be 1. And our element is also 1. So I will find that number of elements which get deleted in the range 1 to 1. It's actually will be 0. So one more operation, 3, 1, 4, 1, 5. So according to the logic I have implemented, the answer should be 5, but it's giving 6. So let's check where is the error in the solution we have. Where is the problem in the solution? So let's do solution problem. Okay. Absolute of IND minus IND plus 1 z plus equal to z. Yes. IND to IND1. Number of element get deleted. C out x. Let's see out x. C out xy. Dot x y. I will check that its logic is working or not. So it's basically x, y, and I get 10. So let's check it what it's actually giving me. So I have to write. Oh, ho, 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 ho. That's it. It's actually IND one. So first time it should run this. So we have to write here IND and one. It's giving. Here will be IND 1 plus 1. IND then minus 1. Let's 0 0 0. The output is 3. Basically, it's giving 0 0 0. That's correct. Why it's not adding the value? X is 0. IND minus IND 1 z plus z. Actually 0 z. No. So we have to do this now. We have to update for changing IND 1. See, that was correct. But it's 5. C or Z. X Z X Z like that. 0 1. Why it is 0 1? How- What IND 1? C or IND space IND 1. So 2. So IND 1 minus IND. IND 1. Here also will be. Subtraction there was some problem. No, we are doing. That's why it was not working. The IND. Let's see it's giving or, or not. It's actually giving correct output on all these cases. Commenting. I'm just submitting. Let's see it's working or not. Should work. That we are 7 and but it's 5. 15 minus 19 minus 15 19 5. So minus 15 minus 19 and 5. 5, 5. 0 1 2. So minus 19 minus 15 5 1 0 2. This is the vector after sorting we will get. Now IND is 2. This time we will fix the element at first index. So the operation we will do is, and our index will become IND 1 plus 1, that is 2. IND 1 become 2. After this operation will become 2, and your IND is going to be, okay. Now we'll pick the second element. Your IND will become 0. 0 is in the left side of, basically 2 is at the, want to delete 0. So want to delete 0 and front is 3 minus 1, that is 2 minus 2 plus 1 minus 2 plus 1, n minus 1 minus IND equal to 1 2. Yes, this is the, so this is your, so this is your IND, your IND. Want to delete this element, this range is in the top, and the number of elements n to IND, then you will find 0 to IND 1, 0 to IND 1, IND to n, and 0 to IND 1, IND 1, IND 2, n minus 1, 0 to IND 1, okay. N minus 1 minus IND minus 1 minus IND plus 1 minus x plus IND 1 plus 1 minus y. So have, let's say we take working on.
Please, cover me. Cover me.
So so it's giving wrong answer on these test cases. So let's check it. 6 18 13 minus 15, 18 minus 15. So 6 18 13 minus 15, 13. So 1 2 3. So after sorting it will become minus 56 13 minus 15, nothing but index 3, nothing but index 0, 13 is but index 2, nothing but index 1. So 3, initially we have IND equal to 0. Let's say the deleted element, okay. 1 2 3, we have 4 elements. So this is going to be an index. If 1 is present, that means that element is got deleted. First 3, we want to delete 3, next 3, and the front position is 0. 0 minus 3 is going to be 4 operation we have to do. and 0, 1, 2 is got deleted. 0, 1, 2, so on. A similar manner, so if your IND got updated with 3 plus 1 modulo is equal to 0. So your IND again become 0 after 4 operation. So again, you want to delete element 0 to 0, number of element deleted. So again, number of operation will be 1. After that, 0 is also got deleted. 0 plus 1 modulo 4 is basically the 1. So IND becomes 1. Now you want to delete the index 2 and the front position is 1. So 1 to 2 the distance is 2. Basically you have to do 2 operation. It will become, your index will become 3. It will become 3 and the operation you will need 3 now. 1 to 1 to 2. It's basically the number of operation will, and your index is got deleted. So 2 plus 1 modulo 4 is 3. So your IND will become 3. Now you want to delete index 1. So number of element, the number of operation will be simply 1. 4, 2, 6, 8. The answer should be 8, but it's giving 9. But it should give 8. It's not giving 8. So there will be some problem. It's giving fourth test case is only the 0, 3. First time it will enter in the loop and it is giving that the else loop should execute now. It's IND 1. That's basically 0, 3. But let's run it again for see what it is. Logic basically we have implemented is correct. Somehow it is failing. There will be some problem. We'll look for that. No problem. Sorry for that. We will look for that. The test case, it should give 8 using this logic, but the logic doesn't have implemented well where it is failing. So it's giving 0. Exactly, it's giving 0. Why it is print 4? Or check 4. 4. Okay, XYZ, put it here. That's fine. Control C, Control V, comment it out. How about XYZ? And this is the case we have. And similar manner we can not see out. Now we will check what's the issue behind it. 0, 4 problem. 0, 4. Not a problem. Going to be 0. So it's good. 1, 2 going to be 0. It's giving 0 constantly. It is giving 0. I think the segment is not working. Set IND 1, 1. So in the fourth test, it's giving 0, 1, 2. X. X is IND n minus 1. giving xy is 0. 0 over 2. C dot ind C dot ind1 C dot. So the logic is correct. 1. So ind 2 3. Third index related. 1 now. Now 7 is not working well. We but resize. Well, some issue I think. I think secondary is not working well. We will look for some another segment. Vector of int segtree to it. So let's dot resize comma 0. Build 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 segment tree 0 to 4n. 4 into build segment tree 1 go to n minus 1. Let's have 1 n minus 1. Let's say we have a vector at 1 n comma 0. I am putting, let's put that back comma back 1. So build it, vary in the range in some query. Yeah. In some query segtree code. Segtree tell notes best. I will put will write my own. I will write. This is the build YLD building tree. After building, remove this line. This side of this here. Segment segtree array. Updating array. We have updating array. We have build tree. We have the query. Query. 1 comma 0 to n minus 1, huh? And ind to ind1, that's it. So similar manner we have query. So we have update also now. So we have to call update. So let's we have update 1 to 0 to n minus 1, 1 comma 0 to n minus 1, and we have ind1 we have, and then we have 1. The similar manner the same thing goes for here. So query query, let's query query query. Okay. Now one more thing I have to update. So we have update 1 comma 0 comma n minus 1 comma, and one more thing we have ind1. Have ind1, and at this ind1 I'm going to put value 1. We have update again. Query will go like that now. G1 comma 0 comma n minus 1 comma, like this. So we have 1 comma 0 comma, or the second argument is n minus 1. So this is the thing we have. Now what we can do the next? query. So I have to first have a build function. Void uild build int ind comma int ss comma int se comma vector of int back. So don't we have vector? Okay. So ild build into ind comma ss comma build, just like this. So build 2 into ind plus 1 comma build plus 1 comma se, and after this st of ind equal to st of 2 into ind plus st of ind 1. Our ss plus se divided by 2, and if ss equal to st of nd equal to, so again we have query are by query. So int int comma int ss comma int s comma int l comma int r. By 2. So yeah, code code limit. By the way, so this code. Update. So I will These are the functions I built. And I have the function. Okay. Then we have it. It. To use this update. Then I have query. I have these are the I have. There is one thing I'm missing. Is vector of int 3 comma a dot h 4 into n capital A equal to back 1 build 1 comma 0. We don't need this back 1. Start with of it. You have a query. Oh, we have it is like this. Okay. Okay. The whole segment implementation. Not we need anything. It's correct or not. P dot resize for it back profile. Okay, it's good. It's running correctly or not. So it's giving correct answer 8. There was some issue in the Taco implementation. It was very because of its that's wrong. They are suffering lots of problems. So now it will work. Segmentary plus greedy part we have with segmentary and so it got accepted. You can see we have used segmentary and greedy. Basically the solution we have used for DQ solution using DQ that got failed. This is the perfect solution we have. So try stopping the video for this. Try the next